Okay, so today, well, I guess first, I'm, as Akram said, a professor in the economics department at Colorado State University, which is about 50 minutes or so up the road from CU Boulder, where Akram got his PhD at Boulder. University of Colorado Boulder is sort of our big brother. Colorado State University is maybe the little brother. So great to have that connection. So I'm going to talk today. So my research is largely in the area of the economics of climate change. And so this is intended as something of an introductory lecture on that general topic. Though I'm going to conclude with some thoughts on the possible relevance of climate change and the economics of climate change for Armenia. So hopefully we'll hang that on. All right, so you may have heard the field of the economics of climate change rose somewhat in prominence over the last year because the Nobel Prize was awarded in part to William Nordhaus, who's the guy on the left. So he shared the prize with Paul Romer, but they're both sort of studying long-run macroeconomic phenomenon, and Nordhaus sort of pioneered the field of the economics of climate change by incorporating explicit climate change models into models of long-run economic growth. And in fact, some of the slides that I'm going to draw on in describing some of his work, actually I took from his Nobel lecture just to make sure it was current. So much of environmental economics tends to be interdisciplinary. I know a number of people here come from the environmental side as well as the economic side. So climate change is definitely the case. So in order to understand sort of the analytic structure of the economic problem of climate change, we have to have some sense of the background science. So I'll start with just a couple observations on the science. I won't go very deep, but a couple things we can see. So I'll start with a couple points that are sort of clear beyond any debate or doubt. So the first point is that global average temperature, global mean temperature is rising. So this is a graph. There's actually several government organizations around the world that independently compute these statistics. I'm here showing data that's been assembled by some researchers at the University of California, Berkeley, but there's various alternative series I could show you, but they all look basically the same. So this is comparing the average temperature of the Earth between 1951 and 1980 is 0. And what you can see is, so if you went back to 1800, 1850 or so, around the start of the Industrial Revolution, which is the beginning of when human beings started burning fossil fuels on a large scale. Initially, not a very large scale globally, but eventually it was. So before the Industrial Revolution, human beings weren't really impacting the climate system at all. But you can see kind of the average temperature back here was on the order of -2, -0.3 degrees centigrade compared to the average from 1950 to 1980. And then in the last 35 years or so, temperature's risen pretty dramatically. And so it's not really the temperature rise so far that's alarming. It's really the trajectory of where global economic growth is headed and what that implies for where global temperature potentially is headed. So we know that temperature is rising. A second thing we know is that the concentration of carbon dioxide in the atmosphere is also rising. So there's a famous observatory in Mauna Loa, Hawaii, where they've been measuring, they've been sampling carbon dioxide from the atmosphere kind of on a weekly or monthly basis going back to 1957. And so you can see this series, it's sort of a fascinating series because you can see effectively the Earth breathing. You can see the difference between the winter and the summer, where you might say the northern and southern hemispheres should average out, but it turns out most of the landmass of the Earth is in the northern hemisphere. So when it's summer in the northern hemisphere, there's a massive growth in trees and plants and green things, and then in the winter they die and release carbon dioxide. In the summer they breathe them in. So you have this consistent oscillation of CO2 concentration in the atmosphere. But the more dramatic thing is the steep secular trend of rising CO2. So if you went back to the beginning of the Industrial Revolution, CO2 was on the order of 280 parts per million, and we're now over 400 parts per million. So CO2 is rising. The reason it's rising is also clear. So it's caused by basically two things. One is the large-scale burning of fossil fuels for energy as an input to all kinds of economic activity, mainly coal, oil, and natural gas. And it's also caused by land use changes. So as human beings, as the world is more urbanized and there's fewer trees, the trees uptake less carbon dioxide and has roughly the same effect as higher emissions of carbon dioxide. So we know these two things sort of beyond any doubt. A third thing that we know, I don't have a slide on it, but because I don't want to get too much in the weeds of the science, but a third thing we know is that there's a basic mechanism that physicists have understood since the middle of the 19th century, which is referred to as the greenhouse effect, which basically says that the reason the Earth is a lot warmer than space is because we have an atmosphere that hangs on to heat, that traps heat. And a key, so there's different greenhouse gases that trap heat. Water is the most important one, but water doesn't accumulate too much in the atmosphere because it rains when water accumulates too much. Carbon dioxide is another greenhouse gas, but carbon dioxide, once it goes in the atmosphere, it kind of doesn't go away. So the half-life of carbon dioxide is 150 years or so. So we pump carbon dioxide into the atmosphere and it's going to be there for hundreds of years. So we know that if we pump CO2 into the atmosphere, it should cause the temperature of the Earth to go up. But it's a little bit more tricky to conclusively prove that the observed warming is conclusively caused by human causes. So being able to establish, this is a problem scientists refer to as the attribution problem. So is the observed warming that I showed you on the first slide, is it actually caused by rising greenhouse gases due to human causes? So there, for a kind of summary of what the state of the science is, the best place we have to look is something called the IPCC, or Intergovernmental Panel on Climate Change, which was established by the UN back in 1987 or so. And it's basically a group of scientists, a couple thousand scientists, that every 5 or 6 years write an assessment report on the state of the science. And one of the things they do is summarize the state of the science for policymakers. And so so in the 2001 report, regarding this question I referred to, are human beings the cause of the observed warming? The language used in that report was that most of the observed warming over the last 50 years is likely to have been due to the increase in greenhouse gas concentrations. And the language is intentionally probabilistic. So likely is reserved to mean roughly a 66% chance, 2/3 probability, give or take, of being true. So in terms of sort of subjective probability terms. So so in 2001, scientists were not positive that it was human caused. So there was still quite a bit of uncertainty from the perspective of scientists. In the next report, which came out in 2007, the language for the same statement was elevated from likely to very likely, which was meant to mean about 90% certainty. And if you step forward to the most recent report in 2013, the language was strengthened to extremely likely, which meant like 95 to 99% certainty. And if you look at there's actually, I won't show any graphs, but you can look at the temperature series and the time over which human beings have actually been elevating CO2 in the atmosphere, and it makes sense that it took a while for the kind of logic, the probability updating logic of scientific evidence to accumulate sufficiently that we were more or less positive that it was human caused. And since 2013, in 2015, it was the warmest year ever observed in world history, or since thermometers have been around. 2016 was warmer yet, and 2017 was warmer yet. So we had 3 years in a row of the warmest year ever on record. So the evidence has gotten stronger and stronger. So it's fair to say that finally, after decades of debate, much of the world is now in lockstep. Climate change is real, the science is real, but if you look at the policy response, it's anything but convincing. And unfortunately, my country is at the lead of the lack of convincingness. Okay, so why is climate change an economic problem? So you might think of it mostly as a problem for science or natural scientists. Why why should we think of this as an economic problem? So I'm going to suggest a few answers to that question. So the first is that the emissions, carbon dioxide emissions that cause temperature rise are ultimately the byproduct of economic activities. So this is true. So you look at modern economic life in Armenia and anywhere else, virtually anywhere else in the world, it's heavily reliant on the combustion of fossil fuels, which leads to the emissions of carbon dioxide. So heating and cooling homes, in Armenia, I think 95% of homes are heated with, well, maybe 95% of the homes have access to natural gas at least. Maybe there's a lot of bioenergy also, but natural gas heating in homes or electrical heating in homes all primarily cause carbon dioxide emissions. Transportation by cars, trucks, motorbikes, airplanes, various industrial processes, agricultural processes, electricity for all kinds of uses, including charging cell phones and other things, right? So, et cetera, et cetera. So it's hard to think of any major sector, of the economy that's not heavily reliant at this point on fossil fuels. So it's really this fundamental dependence of the world economy on fossil fuels that's at the heart of this problem. A second reason this is an economic problem is that emissions are what economists would call an externality. So this picture is sort of reflecting the idea of an externality in kind of a silly way. So two people are eating their salmon dinner, and 2 tables over, someone's smoking a cigarette, and the people eating the dinner don't like the cigarette smoke, and it's sort of affecting them. The person smoking isn't thinking so much about the impact of their cigarette on the people 2 tables down, but they're breathing in the smoke. Maybe in Armenia, people smoke enough, people don't even notice the smoke 2 tables down. In America, they banned it, so now we notice the externality more acutely if someone actually is smoking. An externality, in particular, this is a negative externality, as the economists in the room know, and anybody else may know, is sort of defined as arising when there's harm from an activity that falls outside the producer of the activity, outside whoever's engaging in the activity. So a leading example of this is pollution. So why does this matter from an economic perspective? Well, it turns out that externalities in markets typically lead to social problems, and the reason is that you can accurately think of it as markets don't see externalities. They don't see the harm from externalities. So the way you can think about this, so what is a market and what is it that the market sees? Well, a market is just, it's basically an institution where you have buyers and sellers coming together in a more or less unencumbered way and engaging in mutually agreed transactions. So I could be selling kebab, and I make my kebab however I make it, and I sell it on the street. And when you buy the kebab from me, you don't buy it from me unless the price is agreeable to you and a better price than you're going to get for the quality that I'm selling from someone else down the street, right? So it's a mutually agreed upon exchange. When there's an externality present, if I'm dumping pollution in people in a neighboring village when I produce my kebab somehow, that cost isn't something that you, the consumer, see. So you don't take that cost into account when you think about what you're willing to pay for the kebab. And similarly, if I'm dumping it on someone else and not myself, I may feel some bond through human sympathy that I don't want to hurt somebody else, but if the people being hurt are far removed from me, I'm typically not going to think very much about that cost. So that's a cost that arises, that's a byproduct of economic activity, that doesn't actually isn't taken into account by either the buyer or seller in the transaction. So as a consequence, the aggregation of thousands or millions of transactions in a marketplace ignore the harm from the externality. And that's true of any externality. And so many of the most important social problems in society tend to arise in situations where there's a free market, but there's no regulation to account for externalities. So in economic terms, we refer to this problem as a market failure. And the idea actually goes all the way back to Adam Smith at the beginning of the modern study of economics. But the idea is that anytime the outcome of a market system leads to outcomes that aren't in our collective best interest, and the market's doing something that's not in our collective best interest, we'd rather be somewhere else, then we call it a market failure. And interestingly, if you look in the United States in the 1960s and before, in the US there weren't any federal regulations protecting the environment until the 1970s. And in the 1960s, my mom actually grew up in a place, Cleveland, Ohio. And in 1967, there was a major river that flowed through Cleveland, Ohio, and it actually lit on fire because there was so much pollution in the water. And it was just externalities of chemical companies dumping chemicals in the river that, in that case, was acute enough that it led to an egregious environmental problem. Of course, these problems exist all over the world, no doubt in Armenia as well. Whether or not the market failure is a big deal or a small deal doesn't really depend on the market. It just depends on the nature of the technology, the nature of the chemicals, the nature of the problem that we're talking about. So whether or not the market failure from climate change turns out to be a big deal or a small deal ultimately will depend on how big a deal climate change turns out to be for the world. By the way, you're welcome to ask questions at any point, so feel free to raise your hand if I'm talking too fast. So there's a famous study on the economics of climate change that came out in 2007 by a British economist at the London School of Economics named Nicholas Stern. It was commissioned by the British government. It was called the Stern Report on the Economics of Climate Change. Some aspects of the report are sort of controversial, but he had some elegant language that he used in the report that is used in a lot of cases. And he referred to climate change as the greatest market failure the world has ever seen. And he had sort of three reasons for arguing that climate change is a particularly large or important market failure. The first is that the impacts are potentially very large, impacting the entire world, the entire planet. The second point is that, so if you think back to the case of an externality where you're smoking in a restaurant and you're hurting somebody 2 tables away, you can imagine lots of situations where through human sympathy or maybe some kind of conversation or argument, you might decide, okay, I realize I'm destroying the dinner experience for these people on a date 2 tables away, so I won't smoke maybe, or something like that. It's at least conceivable. In the case of climate change, the impacts are so a CO2 molecule that's released when I fly from the United States to Armenia, or the many CO2 molecules that are released, travel around the world many times within a year. So they zip around, they stay around for hundreds of years. And so ultimately what that means is that it doesn't make any difference where the emissions came from, whether they were emitted in Mexico City or Washington, D.C. or Yerevan or Beijing or wherever. They have the exact same impact on the global environmental problem. So as a result, basically damages from the US impact everyone around the world, including Armenia and other faraway places. But they also impact future generations. And in fact, so most of the damages are on people who haven't even been born yet. So the distance between the actor and the people being harmed is immense. And it's very, very, it's the exact opposite of the smoking in a restaurant case. So it's hard to even imagine what the harm is that you're doing or who the people are that are going to be affected. And another reason is that the problem is the aggregation of literally billions of decisions made by billions of consumers around the world every day, millions of firms, thousands of governments, etc. So there's this incredible, it's not a problem where one ethical individual acting alone can possibly make any progress on the problem. It genuinely will require coordinated government policy. So for all of these reasons, it's a particularly pernicious form of market failure. Okay, so if we want to, I'm going to talk about various aspects of the economics. I'm going to turn to a question that ultimately motivated Nordhaus, who won the Nobel Prize for studying this stuff. And he was interested in asking the question, so if there's a market failure, the way you correct the basic way to correct a market failure in economics is to price the unpriced externality. So the problem is that people don't see a price when they choose to emit CO2 into the atmosphere, but there's social harm that's created. If you were to have a way to impose that cost on the people, on the actors making the decisions, then the economy would sort of steer itself in a way that you could actually recover what's in our collective best interest, or the socially optimal behavior of the market. So to answer that question, we have to be able to figure out what is the price that we should put on a unit of CO2 if we're going to put it into the atmosphere. And if we're going to have a price on that, we actually have to figure out what are all the damages that are done. So a lot of what Nordhaus has done is think about what are the sectors of the economy that are most impacted by climate change, and what are the various outcomes that matter to people, that matter to societies, and that people would be willing to pay to avoid. So, this is listing, in his opinion, the 6 most important categories of impacts. So I'm not going to talk about these in depth, but I'll differentiate them in a couple ways. So the first sector that's obviously impacted is farming. Although, if you think about it for very long, you realize that the impact on farming is fairly complicated. If you were to ask what's the impact of higher temperature on farming in Armenia, raise your hand if you think that's likely to be bad. Is higher temperature likely to hurt farming in Armenia?
Temperature rise means more water for irrigation, more stress for the vegetation. So this is the yields will be dropped, and the cost of the product will increase.
So insofar as precipitation is impacted, is negatively impacted, you'd expect farming to be negatively impacted, right? The temperature, so it's complicated. The impact on precipitation varies regionally.
Evaporation, I mean.
Right.
Evaporation.
Evaporation from the soil, yeah, that's right. So you get drier, the soil becomes drier. So arid places will tend to become more arid. Some places will become wetter on net. The higher temperature probably would lengthen the growing season. It's conceivable that Armenia will actually, I don't know this for sure actually, but it's conceivable that Armenia will actually benefit to some degree. You don't think so? Okay, so that you know more about it almost certainly than I do.
No,
Jesus, climate change.
Okay, perfect. So what a lot of the global economic models suggest is that the location of farming is likely to move. A couple degrees centigrade temperature is probably not going to negatively impact global production of farming, but beyond a couple degrees centigrade, it could be devastating. So it's probably highly nonlinear in temperature, but there's the potential for it to be very negative. In the U.S., the expectation is that the areas where there's huge amounts of wheat production today will likely no longer be producing wheat in 50 years, but areas to the north that are too cold for wheat production now, or areas in Canada, may become huge wheat centers, say. So the location of farming is likely to move a lot, with a lot of negative impacts on certain regions, but some places could benefit. So the impact on farming is complicated. Yeah,
I just want to know how we are going to measure the impact or the damage. So how are we going to measure to say, okay, if you produce a 1 unit of product, then you should pay $1 for the damage or environment. So how we are going to measure the damage?
So the way that Nordhaus does it is he thinks of all the different major sectors where you're likely to have lots of damages, and then he adds them up globally, and then he considers the impact of an extra ton of carbon dioxide on, actually it's a complicated model. It's a very difficult question. So he has a model that has about 40 mathematical equations that includes the climate, the carbon cycle, which describes how carbon accumulates in the atmosphere, the impact of temperature on, the impact of CO2 in the atmosphere on temperature, the impact of temperature today on temperature tomorrow, so there's inertia in the system, but and then ultimately the impact on economic damages. So it's somewhat of a speculative, ambitious thought experiment to build a model that has all of these pieces, but there are models that people build that have been around for 20 or 30 years that have been probed and tested and tried, and some of the assumptions that are known to be less confidently known are sort of, there's ongoing research in those areas. So it requires this kind of integrated model to think about it, and I'll talk about those models in a bit. But first you have to add up all of these damages within all of these different sectors to think about it. You're right, it's not obvious how you would do it. One of the takeaways from Nordhaus is that there's a big difference between areas of the world or things that people care about that aren't managed versus things that are managed. which has to do with the fact that most of these damages are happening 50 or 100 years from now. And it's very hard to assess what technology will look like. If you were to go back 100 years and ask what the world would look like today, there's been an immense amount of technological change that has the potential, at least, to mitigate impacts. So impacts in sectors like farming, impacts in health risks if malaria has farther reach because of temperature change in the earth. Those are all things that could at least in principle be mediated by technology. In contrast, things like rising sea levels, which I'll talk about shortly, as well as acidification of the ocean, which is a separate impact of rising CO2. Basically, CO2 gets saturated in the ocean, and it turns the ocean into carbonic acid and lowers, so the pH of the ocean is becoming progressively more acidic. And that impacts crustaceans and the basic, like the foundation of life in the oceans. And it's very, it's hard to imagine how we can contain that if CO2 rises. So,
You'll need to connect to the internet first.
That's right. Anyway, these are all areas where they're unmanaged. I'm gonna actually, for the sake of time, keep moving. So, sea level rise is a potentially large issue for many places, though fortunately not for Armenia. Fortunately or unfortunately, it's at least not a concern. So, but sea level rise. So parts of the world like Vietnam have massive population centers. Vietnam, Bangladesh, actually the U.S. has Miami and other places. Large portions of population are a meter or so above sea level. So the IPCC forecast for sea level rise by the end of the century is on the order of 3/4 of a meter by the end of the century along the current path. And you might ask, what does that mean for, the more acute thing is so if you look at, so sea level rise is caused by two causes. One is that higher temperature causes the water to occupy more volume. Another is you have melting land-based ice from the poles, basically. And it turns out that if all the ice at the poles melts, the ocean will rise by about 70 meters. So 270 meters, 210 feet, which is immense. Fortunately, it happens very, very slowly. So within the next century, the expectation is that it'll be less than a meter. And over the next 500 years, along high temperature scenarios, the IPCC has it at about 6 or 7 meters in 500 years. So this is catastrophic for many coastal cities, but it's 500 years out. So it's a slow process, but it's sort of a looming disaster for many parts of the world. So this is a major concern. Okay, so that's a very, very quick discussion of some of the impacts of climate change. How do economists think about this problem in terms of costs and benefits? So back to the question that was raised. So how do we figure out what the carbon tax should be, or what the social cost of a ton of carbon dioxide is? In order to do this, economists pioneered by Nordhaus, who just won the Nobel Prize, have developed what are called integrated assessment models that are used to compare the costs and benefits of climate change. And so the model that Nordhaus developed has the acronym DICE, the Dynamic Integrated Model of Climate in the Economy. It was developed over several decades, and I'm going to quickly talk about that model and some of the high-level conclusions of the model. So this is a model that's somehow sometimes described as a circular flow. So you have a model of economic growth that sort of forecasts what global economic activity is going to look like over time. Higher economic activity, depending on technologies which are part of the model, lead to higher emissions, which accumulate in the atmosphere, which cause temperature rise, changes in precipitation patterns in different parts of the world, sea level rise. That then impacts all kinds of things that people care about, including economic activity directly, including ecological processes and things that people care about, and other things, ocean acidification, etc. Then the model allows for the introduction of policy, some sort of policy instrument that can curb emissions at some cost and takes into account how costly that would be. And if you curb emissions, you lower the accumulation of CO2 in the atmosphere over time. But by expending money on abatement, you're foregoing investment that you could have made in other sectors of the economy, which ultimately feeds back on economic growth. So there's this sort of interconnected piece, as I described earlier. The model is something with 40 or so mathematical equations, and it's typically solved in a computer. But it allows you to sort of get a number for the carbon price, or a number for what we should be taxing carbon at if we could do it. That depends on a lot of assumptions, and then you can vary the assumptions and answer the model under different assumptions. So the model adopts the perspective of a kind of global planner who's seeking to maximize global welfare. So Varfram, just to be clear, what time should we aim to finish? 7:30, okay. So I'm going to try to go a little faster. So I'm going to describe this is actually the way, I'm going to take a few slides from Nordhaus's Nobel lecture where he describes the outcome of his model, and he basically compares a few different policy options. I'm going to focus on sort of these first three. So a business as usual scenario is like the trajectory of the world economy without any policy. So what's the path we're sort of more or less currently on? What would be the optimal according to his cost-benefit analysis, according to his model if we behave optimally? And that ultimately depends on how damaging climate change turns out to be, and he considers two alternative damage functions. And then he considers scenarios where we put a hard cap on carbon emissions. And so this shows the temperature of the Earth according to his model. So in 2010, we're already somewhat, 3/4 of a degree above what temperature was before the Industrial Revolution. And according to his business as usual model, which is in line with IPCC scenarios that are typically considered, by the end of this century, temperature will go up by about 4 degrees centigrade, and it continues to go up. So to put it in perspective, the last time the world was 5 degrees centigrade warmer was 55 million years ago, around the time of the dinosaurs, and at that point there was no ice at the caps. So the sea level would have been 70 meters higher than it is today. There were supposedly alligators in the Arctic, and Spain was a desert, right? So that's a very different world. In his model, under his standard damage function, which doesn't have climate damages being as acute as some other models assume, his optimal path actually involves fairly gradual intervention and doesn't do that much in the short run, but over the long run it stabilizes the climate system. And with a more acute damage function, he comes down here, and then if we wanted to lower emissions to keep temperature below 2 degrees centigrade, the temperature would look like this. And if you consider the trade-offs, if you consider basically the present value of future damages and compare those to the present value of future abatement costs, in his baseline scenario, the damages he adds up amount to about $23 or so trillion present value in damages to the world, and there's basically no abatement. His optimal, sort of depressingly, involves a relatively little amount of abatement, and it lowers damages by this amount in present value terms. And if you were to hold temperature to 2 degrees...
Can you just explain what the word abatement means, because the audience may not.
Yeah, absolutely. Sorry, thank you. So abatement just means reduction in emissions. So in order to reduce emissions, you have to curb some sort of economic activities. You have to switch from coal to renewable energy or something like that. So abatement tends to be more costly than no abatement. And so you're incurring, so the basic idea of this model, so one way of thinking of these models is that there's a whole bunch of assumptions, and so there's a lot of uncertainty, there's a lot of connected pieces. But the gist of it is that it allows you to balance trade-offs or think about the trade-offs. So as you incur costs, so are you lowering damages by enough to justify the investment in abatement, in the reduction of costs? Okay, so the topic I just talked about is this sort of question of what's the right amount of abatement? What's the right amount of cost that the world should incur? So without conclusively giving you an answer to that, if we look at the world today, one thing we can see is that we've made very little progress on this problem. So we've been talking about climate change at an international scale for about 30 years. But if you look at the trajectory of global CO2 emissions, they're roughly linear and rising and on the order of 1.8% per year, despite various international agreements. So as I mentioned, CO2 stays in the atmosphere for a long time. So it's what's called a cumulative pollutant. And you can think of it as a kind of sand pile. So as we emit carbon dioxide, we add a shovel full of sand to the sand pile, and the sand pile gets bigger and bigger. And that means the concentration of CO2 in the atmosphere gets higher and higher. And in order to stabilize the climate system, we actually eventually need emissions to drop back down towards zero. Otherwise, we're constantly rising CO2 in the atmosphere. And the world has this kind of steady rising trajectory of CO2 emissions. So whether we think the carbon tax, the optimal carbon tax, should be the higher version of Nordhaus's model or the lower version, it almost doesn't matter, because it's sort of like where economists are arguing about the right level to increase a bathtub to. What should we raise the bathtub to this height or to this height or to this height? But actually there's no drain, and we're effectively making no progress. So it's quite discouraging when you look at the international landscape and progress that we've made. So to understand why the problem has been so hard, we need to think a bit about, so how many of you ever heard of a prisoner's dilemma game? Is at least all the economists in the room, not the non-economists. So the prisoner's dilemma is it's a game used by game theorists. So game theory is the economic study of strategy games or strategic interactions among actors, right? So a prisoner's dilemma, the idea of the prisoner's dilemma game, it's a sort of metaphor, but it's been picked up in all kinds of fields, ranging from economics and political science to biology. And it's a very intriguing scenario. So it describes a situation where, so there's two accomplices who have done some crime, and the detective has caught them, but he doesn't have enough evidence to put them away forever. He doesn't have enough evidence to prove that they're guilty. But he can catch them on a small crime, a kind of misdemeanor. And so what he does, though, is he tries to get each of the accomplices to rat out or tell on his accomplice and say that the other guy did it. Of course, it's in their best interest to cooperate and to not tell the detective anything. But the detective invents a sort of brilliant payoff game to try to create it, to try to trick these guys into giving up, into telling their information. So what he does is he says, okay, so the way you read a game in game theory, or at least the way this is shown, this blue player has two strategies. They can either cooperate with their accomplice and not tell the detective anything, or they can defect. And meanwhile, their partner can either cooperate or defect. And the detective has put them in separate rooms so they can't talk to each other. So now the blue player gets payoffs that depend not only on what they do, but on what their accomplice does. So this is the sense in which the payoffs for the game involve strategic. It's actually a game of strategy. So what I do is, if you're playing poker, it's not only what you do, but it's what you do and what everyone else in the game does, right? So it's the interaction that actually matters. So the blue player has to choose between cooperating and defecting. Their payoff is labeled in blue here. So the question is, I'm the blue player, I'm locked in some room and I can't talk to the orange player. But I don't know what they're going to do. I don't know if they're going to rat me out, if they're going to defect, or if they're going to cooperate with me. So I could surmise this way, though. I could say, well, suppose they cooperate. If they cooperate, what's the best thing for me? If they cooperate, I'm choosing this column of payoffs. So basically, if they cooperate and I cooperate, my payoff is 1 year in jail. We both spend 1 year in jail. My payoff is -1. But if they cooperate and I don't cooperate, the detective says I get to go home scot-free because I cooperated and I ratted out my accomplice. The accomplice gets thrown in jail for 10 years. They get stuck with the crime, and I get to go home for free. In contrast, if I think my accomplice is going to cooperate, I'm better off defecting and not cooperating. In contrast, if I think they're going to defect, my payoff is minus 10. I get thrown away in jail for 10 years if I cooperate, because then they go home scot-free and I cooperated, because it's symmetric. In contrast, if I don't cooperate, I only go to jail for 5 years. So if I think they're not going to cooperate, I'm better off not cooperating. If I think they're going to cooperate, I'm better off not cooperating. No matter what I think they're going to do, I'm always better off not cooperating. So, and similarly, my partner has the exact same incentives. So both of us are overwhelmingly better off always not cooperating. So we get stuck in this equilibrium. So we would say the unique Nash equilibrium in this case is don't cooperate, don't cooperate. So with this model, and meanwhile, you look at this game and you say, this is totally stupid. These guys are way better off. Why would they not cooperate? It's overwhelmingly in their best interest to cooperate. We should have this outcome. So the prisoner's dilemma game, in a very intriguing way, describes a situation in which people are collectively better off following some cooperative path, and it's obvious that we're collectively better off, but individuals' incentives push in the direction of this non-cooperative equilibrium. And it provides a deep explanation for the challenge of achieving cooperation. So very quickly, I want to describe a model a model of a climate change agreement that has exactly the structure of a prisoner's dilemma game. So what gives rise to this is, imagine there's a world with 20 countries. So let's just say there are 20 equally sized countries. The nature of climate change is, if I emit carbon emissions the way a country normally would, I create 1 unit of damages that falls on each of 20 countries in the world. So I contribute 20 units of global damages. Okay, so each country's carbon emissions contribute 20 units of global damages. But only 1 unit is felt within my country. So my citizens experience 1/20th of the global damages of climate change. And meanwhile, if we decide to lower our own emissions, change the energy infrastructure of our country to switch from coal to windmills and solar, say, or whatever changes would be required, we have to incur a cost of 10. Okay? So this is a world where the damages created by our emissions of carbon dioxide cause 20 units of damages to the world, to the global population, and the cost of abating it is half of that. So it's clearly in the collective best interest of the world if we abate our emissions, and every country is symmetric, so it's in the collective best interest of the world that everyone abate their emissions. We're much better off with everyone abating and everyone cooperating. But the problem is that when I do that, if I decide to abate or not abate, like in the prisoner's dilemma game, I'm choosing between avoiding 1 unit of damages that falls on me and incurring a cost of 10. And so at an individual incentive level, so we can describe, for the sake of time, just to give you the flavor of this, I'm going to think of the other player as all the other 19 countries working in cahoots, basically. So if we're in a world where I abate and all the other 19 countries abate, then we're in a world where the abatement costs on country A, say Armenia, are 10. The climate damages on Armenia are 0 because there's every country in the world abated. Then the climate benefits are 20, so how much you benefit from all the abatement is 20, so the net benefits are 10. And if you go down, you can compute this for all the different scenarios. And if you throw this in a table just like we had before, where abate is the cooperate outcome, don't abate is the non-cooperate outcome. The rest of the world, I'm not putting the rest of the world's payoffs, but I'm imagining all 19 countries doing the same thing. If the rest of the world abates, I'm better off not abating, because basically I benefit from all the other countries abating, but I don't abate. So my benefits go from 20 to 10 and 20 to 19, and I don't have to pay the 10 in abatement. If the rest of the world doesn't abate, I'm better off not abating. So no matter what the rest of the world does, I'm always better off not abating. And it's a symmetric model, so every country faces the same incentives. So the only Nash equilibrium in this game, the only stable equilibrium from an incentive compatible or incentive sense, in terms of individual incentives, is the don't abate, don't abate. So this is a very simplistic model of international negotiation, and in fact, we can do a lot better than this. But it does describe the problematic nature of incentives in this type of international environmental agreement, and it stems from the fact that there is no global governing body with power and authority to tell the world what to do, right? If the UN had nuclear weapons, it could tell the world, you have to do this, and decide what's in our collective best interest, and China and the US and everyone else would go along, then this problem wouldn't be so pernicious. But it's the absence of international institutions with authority, with power, to force the major fossil fuel emitters in the world, like the US, to do what's in our collective best interest, that makes these incentives particularly pernicious.
Terry, what's confusing about the analogy with the prison's dilemma is because in the case of prison's dilemma, there's lack of communication between the two.
Yeah.
Whereas in this case, everyone's talking to each other. There's no lack of communication.
So you could have communication in the prisoner's dilemma game, but it would be what game theorists would call cheap talk if you can't sign a binding agreement. So it's not just the lack of communication, it's the fact that you can't, because you and I could talk, and of course I'm going to tell you, I'm not going to rat you out. Of course I'm not going to rat you out. We've been brothers for years, and we've been through everything, right? So of course I'm not going to rat you out. And then as soon as the detective asks me my vote, I'm going to rat you out, right? And you're going to, there's nothing to keep me from doing that. So it's the absence of a binding agreement. So in the case of what does change things potentially is, so you have repeated interactions, which change the nature of things. So obviously with repeated prisoner's dilemma games, you can get cooperation, although it's still difficult. But I'm actually going to turn to a more compelling outcome, a more compelling solution. So actually Nordhaus has an interesting suggestion. He refers to it as a climate club. So this came out in a paper in the American Economic Review in 2015. And the basic idea here is so the incentives for lack of cooperation in an international environmental agreement that I just described are referred to as the free rider problem. So economists talk about free rider problems anytime there's a public good provision problem. In this case, the idea, so a club, so what's an example of a club? So a good example of a club would be the World Trade Organization, or it could also be a fitness club, if anyone's ever belonged to a fitness club. So the way a fitness club works, you pay a membership due, and then you can go as many times as you want. The membership due is used to build this beautiful facility with all the exercise equipment you could ever imagine, and all these lovely things. In fact, you maybe show up 3 times a year, or if you're me, you do. But the idea is that you pay entrance to the club, and then we pool resources effectively to build this beautiful facility, and you can go anytime you want. The World Trade Organization works by having member countries pay dues of some kind to be admitted to the club, but then they get the benefits of regulations governing free trade. The way a climate club would work is that the dues that people pay are to abate their carbon emissions. So we agree to abate carbon emissions by imposing some carbon price on our local economy, say a carbon price of $20, $25 per ton of CO2. The benefit of doing this is that we get access to a free trade agreement among all members. So if you're not a member, you get hit with a tariff. You get hit with a trade tariff. Why is this important? Effectively, what this does is it couples the issue of climate change with something that's really economically valuable to countries, so that they're willing to incur the cost of benefiting the world in exchange for participation in the free trade agreement. And so what Nordhaus does is write down realistic description of this kind of interaction. And ultimately, the climate club overcomes the free rider problem by creating a strategic situation in which countries acting in their own self-interest will choose to enter the club and undertake high levels of emission reduction because of the structure of incentives. So this graph is showing so he uses a version of the DICE model with like 12 regions of the world that are interacting strategically. So it's a little somewhat complicated, but you don't have to worry about it. But what this is showing is, suppose the tariff that the club charges is there's no tariff. Then in this model, the amount of countries willing to enter into the climate agreement that involves a carbon tax of $50 is 0. So basically, no one is willing to enter. if you raise the tariff to 1%, am I reading this backwards? This is.
You
Yeah,
can't
no-
see,
no
I think you
tariff.
can't see the zero.
Oh yeah, here it is. I'm sorry, you're right. So you don't start getting participation in the climate club until there's a fairly high, it's a minimal level of tariff. And if the tariff is raised to like 8 or 9%, then you actually get most of the countries of the world. In this case, there's 14 regions, I think. So this is full participation. So that this is really kind of a sketch of an argument. But the gist of it is that in his model, it takes a fairly substantial tariff. Basically, you have to have a carrot big enough for countries to be willing not to overcome their incentive to free ride to agree to participate in the global climate club. And if that carrot's big enough and the world agrees to use that carrot, then
What is
then
the
you-
tariff here, right? What's
so the tariff amounts to, so the arrangement is, so if you're in the club, everyone in the club agrees to tax carbon at $50 per ton of CO2, which
In their country,
incurs costs on your country that benefits the world. At the same time, all countries in the club agree with you that they're going to allow free trade with them. You get to trade freely with them. But anyone outside the club gets hit with a 9% tariff on imports, or so it's various different possible tariffs. And as the tariff level increases, the size of the stable coalition in the game theory model among regions rises. So you get full participation at a sufficiently high tariff, basically. And if the tariff is low, or in the case of the Paris Accord, which was signed in 2015, there's no tariff. It's a voluntary agreement. This economic model would predict nobody would actually follow through with their commitments, which is roughly what we're observing in the world today.
Sorry,
Yeah.
but then how do you impose the tariff on countries? For example, countries can say, we don't care, we are not gonna.
It's a trade.
So you can impose it. So the same way that Trump is putting tariffs on China right now. I mean, in this case, not to achieve anything, but his own narrow political interest. But he could. So a country can put a tariff on another country by saying they're going to, right? So there are trade agreements that say we're not going to. But this would the gist of this is sort of an abstract model of a global international agreement that's saying at least if you connect these two issues with something that's sufficiently economically valuable to individual countries, then you can overcome this kind of free rider incentive. And it would amount to basically renegotiating trade agreements in conjunction with a climate accord, which is way outside the scope of anything that the international community is talking about right now, but may in the long run be what's required to actually make sustained progress. Yeah.
Terry, but you're imposing the tariff on goods imported into your own country. So that's how you can impose it. In other words, right, I mean, you're not, no one else has to pay, but when you import a car from that country, it would then cost 10% more. And so that's how you have the ability to
Exactly.
impose the tariff, right?
Yeah, exactly. So physically, when goods come into Armenia could always slap a tariff on it. What's missed in this model is this could of course also incite a trade war among countries, and that could be devastating to global welfare if countries don't have free trade with each other, because that's very beneficial to everyone. But it at least shows that in principle, if trade agreements were linked to climate change in a fundamental way, which would require that the issue was way more important on the international landscape and people prioritized it enough, but at least in principle you can avoid that prisoner's dilemma game problem that I was describing. I think so I was going to tie this back to Armenia. I'll try to do this in 2 minutes. So the question is, so I'm actually not going to put a lot of weight on this analysis, but I'm going to discuss, so there's an expression in English, every cloud has a silver lining, you may have heard it before. There's a paper in Nature a few years ago from some economists at UC Berkeley and Stanford that got a lot of press. And essentially what they do is they use a panel data model to look at, so they have country fixed effects and year fixed effects, but they look at sort of average temperature within a country in a year and have data over a period of time, so you get variation in average temperature within a given country in a year. And they find what they argue for nonlinear relationship between temperature and economic output. So there's kind of like an optimal temperature at which economic activity is highest, and if temperature is too low, then you have less economic activity, and if temperature is too high, you also have less economic activity. Now what you can imagine is that, so what they're going to do is try to use this to estimate the impact of the IPCC or Nordhaus forecasted temperature change in 2100 on GDP of a country. And there's problems with this, so there's a lot of controversy about this. Partly it doesn't account for how countries adjust or adapt to temperature changes over long periods of time, and that's hard to observe. So it's very much imperfect, but I'm going to point it out because it has some intriguing suggestions for Armenia in particular, and some other places. What you get is massive heterogeneity around the world in the impacts of climate change. So some countries have, so on average the world GDP is like 23% lower according to their analysis in 2100. But the countries in red are big losers, and the countries in blue are actually winners. So Canada, Russia are huge winners from climate change because they have, they're cold, very cold places, and they benefit from the large increase in temperature. So if you actually look at their data from this paper, which I pulled up, it has impact of GDP in 2100 for every country in the world, more or less, due to IPCC forecasted climate change. Any guesses on Armenia? What do you think the impact, according to this study, which is actually imperfect and a portion of what climate change is likely to do? Any guesses on what this study's guess at the impact of climate change in Armenia is?
The colors look promising.
What did you say?
The colors look promising.
Yeah. So,
Mediterranean.
so this is showing different regions of the world, right? So if you're in Latin America, you're definitely devastated. Sub-Saharan Africa, definitely devastated. Oceania, Middle East, etc. But Europe and Central Asia have some clear winners.
So we will assume that you are in Europe.
No.
Right. So
Mediterranean.
this is the actual data. So this is their estimate. So they according to their study, which I think is hugely problematic but still intriguing and possibly directionally correct, they argue that Armenia is actually a big winner in 2100. So I would say, so the world average loss is about 23%. The argument is that Armenia is a cold place and potentially temperature rise. So you would definitely disagree, right? So
It's much more complex than just a
it's much more complex, right? So and I would add, so huge caveats. So I just threw that out because they found it intriguing. But a couple of things that are missed. So that study has nothing to do with precipitation. So some places, so arid places are gonna be hurt by climate change. An even bigger issue is that you're gonna have massive dislocations of people. So places like Bangladesh with hundreds and hundreds of millions of people is going to be largely underwater and have mass dislocations with potentially hundreds of millions of environmental migrants, and that can induce all kinds of profound changes in the geopolitical landscape and otherwise. So it's impossible to know what the aggregate effect of all of those kinds of changes are, but there's definitely heterogeneity in impacts, and insofar as there is, Armenia is at least in a better place than many parts of the world. So stay in Armenia.
But if you will go back to the map, so if you can go back to the map.
Yeah.
Because when we are doing projections for Armenia, we are looking for Mediterranean region, and because Mediterranean scheme will be applied also for Armenia as a regional forecast for climate, and for Mediterranean region, Spain, Portugal, Greece are in a bad zone.
Where are you?
Yeah, but they're very different, right? In
No.
terms of temperature.
No.
So you're saying that because of aridness, or
Because of aridness.
okay, yeah, yeah. So precipitation is gigantic
Oh.
consideration.
It's not so much precipitation, but because you maybe know that precipitation forecasts are more uncertain,
Yeah.
particularly for mountainous terrain. But the temperature rise will impact even if the precipitation will stay same. With temperature rise, you will need more water,
Right.
and this is the issue even now.
Right. Right.
Diana
So-
prepares the national communications on climate change.
Okay.
Her office does, so everything Armenia they analyze, and this is what they communicate.
But of course, I'm not saying that we are perfectly right, but this is done for a global scale, and I don't want to that the auditorium will leave
Yeah,
with
yeah,
the
yeah,
impression
yeah.
that Armenia will gain. Even for Russia, there is forecast that Russia will lose all its infrastructure for the melting of the permafrost.
Okay.
All-
So I totally defer to you actually. So I actually this isn't my research.
Permafrost area
Um,
where they have all their oil deposits, all infrastructures, all cities that are built on permafrost will melt, so they will lose all infrastructure, so it will be much costly for them to be relied on the natural resource of oil and gas. They need investments for building new infrastructure, new type of approach for cities, railways, gas network.
Okay. Yeah, I have no. It's an immensely complicated, complex question. So this analysis is simply taking. It's a panel data model that's looking at every country. It has country fixed effects, so it's controlling in a crude way for differences across countries. But it's looking at 1 year Armenia had above average temperature, 1 year it had below average temperature, and then observing GDP in those years, and associating changes in GDP with basically estimating what ends up being this nonlinear relationship between temperature and economic output. A lot of economists have been hugely critical of this study, but it's the implications for the heterogeneity of damages across countries could be revealing in some ways, but it also misses sea level rise. It misses all the sort of it only misses the impacts, like the impacts on farming and health effects and stuff that are in things like the DICE forecast. So it's a narrow.
It's provocative.
It's provocative, yeah. It's sort of trying to estimate what, like, there's relationship there in micro studies. There's there's a relationship between temperature and labor productivity, for example, and it's sort of possibly accounting for those kinds of differences in certain ways. So it may be a relevant input to consideration, but I 100% agree with you that it's hugely problematic and maybe actually completely wrong. So I actually don't want to put too much weight on it, but.
We like the conclusion that Armenia is good.
That's what I was trying to do. It's a very complicated question. So and you know more about it actually than I do. So thank you. Any questions? Thoughts?
So from economical perspective, Paris Agreement is not workable document, which is very painful to know.
That's what most economists.
Where were economists when they were signing the?
I mean, so economists going back to the 90s have been arguing for this sort of game theoretic view of international environmental agreements and arguing that we need to have consequences if countries don't participate. Coming into the Paris Accord, it wasn't clear we were going to do any better than we did in Copenhagen when people just walked away and didn't just stop talking. And I think most people so there was actually an intriguing quote in The Guardian that I can't quite remember it, but basically said the Paris Agreement was far better than anyone expected, but still abysmal compared to where we need to be, kind of thing. And I think that's roughly true. I think it was a step in the right direction, partly towards getting countries to sit at the same table and talk and try to create terms where countries were willing to at least commit marginally, but not. So in these kind of game theory models, kind of intriguingly, what you get some abatement in the Nash equilibrium, where countries are doing what's in their individual best interest, but it's about 1/10 as high as what would be in our collective best interest. So we're willing to do a certain amount, but not what we should be willing to do, given what would actually be in our collective best interest as a global community. So I think Paris is nowhere near pushing us in that direction. There's a lot of talk. The suggestion that we're going to keep temperature to below 1.5 degrees centigrade or 2 degrees centigrade is mostly just political talk in the political theater. But
unfortunately, we don't have Christine Storm here. It was one of our fellows visiting. She did her work on the German energy transition and how all the policy objectives set, and Germans are probably the the advocates of climate change policy, implementation, and yet she's looking at what Germany has done with their energy sector. Yeah, there's great energy efficiency, there's greater penetration of renewable energy, but they have not, and they're far from meeting their climate change goals, the greenhouse gas emission goals. So there's been success on some fronts, but when it comes to greenhouse gas emission reductions, it's been an abysmal failure. So, more to the best case of a country really committed to doing something has not been able to achieve.
Right. And that's mostly what came out of the Kyoto Protocol, which was the first generation global climate agreement, which most countries didn't follow through. Yeah, so I think what a lot of economists have sort of doubled down on is that we have to take these incentive constraints seriously. But it's sort of like the suggestion that we're going to link global climate agreements to international trade agreements is a entirely radical idea that's way outside the...
No compliance mechanism.
Sorry?
No compliance mechanism for the promises.
Right. Yeah, exactly. Yeah.
Yeah, thank you so much. Just a quick question. So if there is no political will, let's say there will be no political will, and everything stays pretty much the same, but there are people who change their consumption habits, people who change their behavioral patterns, transportation habits, may it affect somehow the climate change?
That's a great question.
Like masses of people.
So these are actually, to me, I'm actually trying to do research on this question. It's a tricky question. There's a huge number of subnational agreements in the U.S. around the world. So a large portion of the states in the U.S. actually have their own policies and are sort of frustrated. So you have these sort of pockets of political will. Boulder, where Bahram got his PhD, has had a carbon tax for like 15 years or something. There's very few places with a carbon tax, but there are these pockets of places, and a number of them where there's sub-global effort. And one of the questions is, there's economists who look at sub-global. So one of the problems is you have a kind of leakage in this case, what economists call leakage or carbon leakage. So if Boulder decides to aggressively regulate climate change and introduce a giant carbon tax, what could happen is all of the energy-intensive firms just move to the neighboring town and move their factory. And in the U.S., there's nothing to keep them from doing that, and then their workers can just move over the border, and it's very easy to change the location of the economic activity. So now what you have is a certain amount of emission reduction in Boulder, but then emissions in the neighboring town have risen, all else equal. Maybe not as much as yours lowered by, but there's this kind of leakage problem. And so if you don't have, if the externality is in this case a global externality, if you don't have some way to regulate it at a global level, there's always the potential for leakage. Nations can actually prevent that partly by taxing, say, the carbon content of imports. So if a firm wants to relocate if an aluminum production facility in the U.S. wants to relocate to Mexico, say, and then sell the aluminum back to the U.S., if it was taxed, then they're going to not have as much incentive to do that because of the carbon tax. But if it's not, they might have every incentive to do it. So it actually gets complicated when you have these. So with individuals, you have a bit of the same issue. So what I sometimes speak to groups interested in climate change, say in Colorado, and it's a very awkward thing to talk about because you have activists who are very passionate about the issue and want to do something and want to have everyone ride their bicycle. And that's a fair point, but if as a consequence of that people decide, well, we rode our bicycles, so we've done our work and we did what we could do, and then they don't write a letter to the national government or protest or argue for national policy or for policy or push for global climate policy or something like that, then we may never make progress. So it needs to be, but at the same time, local action can actually stimulate and create an environment and create learning and create momentum for political movements at higher levels of aggregation, but it requires a kind of understanding, a more sophisticated understanding of the problem, where you understand that the individual action alone is probably not going to be enough, and that it's going to require ultimately solving the problem, because it's actually an externality that's the byproduct of billions of consumers every day making decisions, and millions of firms and thousands of governments around the world, we're not going to make progress unless we move in the direction of seriously thinking about a global agreement.
Thanks.
Yeah. Yeah.
Does the economics of climate change consider somehow also methane emissions?
Great question. So I only talked about carbon dioxide, but in fact methane is hugely important also. So methane's a much more potent greenhouse gas than carbon dioxide. It also fortunately stays around not as long. So the half-life of methane is something like, I don't know exactly, 30 to 50 years or something. So, but it's much more, it's like, I think one methane
21.
molecule is like
21.
21 times as powerful. Okay, thank you. I was going to get it way off, so I'm glad you intervened. So methane is a lot more powerful molecule by molecule, and it's increasingly a big deal because of new technologies to access, using fracking and other things to access, growing amounts of natural gas reserves. So so the DICE model, for example, what scientists do is convert methane into sort of CO2 equivalents, and then think about the carbon dioxide equivalents of all the different greenhouse gases.
Oh.
So they think about them, but usually when you sort of loosely talk about the problem, people talk about CO2.
Do you mean the tariff is gonna consider also methane emissions?
Yes, it would. So a reasonable accord would have to consider methane. So methane is something, you could correct me, maybe globally, I think in terms of the overall problem, it's probably 20% as important as CO2, but it's still a big deal. And that, something like that, ballpark. So methane, it's a critical piece of the problem also. So it would have to be taken into account. So you'd have to think about, so a carbon tax would also be a tax. So people refer to it as a carbon tax. It's a tax not only on CO2, but also CH4, which is methane or something. So
interesting.
The term is used as carbon dioxide equivalent. All greenhouse gases are brought to the CO2 equivalent, and when you are calculating the total emissions of the country, you are bringing to CO2 equivalent to be comparable.
Thank you.
yeah.
You mentioned that in order to solve climate change, we're going to have to look at a system of global federalism, right? And what do you think is stopping these state actors? Why is there so much political apathy towards climate change from them?
It's a good, there's multiple aspects of it that are complicated. I actually think to first order approximation, this kind of prisoner's dilemma and incentive is a big part of it. So as an individual country acting alone, most of the damages that are being created are falling outside your borders. And if you decide to change from coal to wind or solar, most, and in fact, likely all of the costs that you incur are going to fall within your borders. So there's this which creates a kind of free rider incentive, as economists would call it. So that's fundamentally what makes the problem so difficult. It's the fact that there isn't a global authority that can tell the world what to do, and individual countries acting alone or acting in a kind of loose environmental agreement where we all kind of voluntarily agree to agree doesn't change the incentives from what they are in the prisoner's dilemma game. That can be changed, but it requires a kind of architecture that is sort of more serious and more requires a higher level of commitment than I think we've observed so far. I think there's also huge vested interests, very, very powerful vested interests. The global wealth embedded in fossil fuels is very concentrated and very powerful. Tens of trillions of dollars of fossil fuel wealth. And so in the 1960s in the United States, it's well documented that when doctors and scientists started to understand the health effects of cigarette smoking, and started advertising that, the cigarette companies aggressively opposed the science and created their own fake science and had all kinds of marketing campaigns targeted at undermining political or people's concern about the health effects of smoking. And we actually, much the same thing has happened, at least in the US, where there's very concentrated lobbying on behalf of fossil fuel interests. that kind of undermine the state of the science. I think it's much different in the U.S. than outside the U.S. There's almost this like the conservative media in the U.S. is hugely antagonistic towards any scientists or people who say that climate change it creates this kind of muddy view where people don't really, unless people care about the issue, they don't bother to understand enough to understand what's going on. So there's a lot of misinformation.
Can I suggest another factor, and use of policy from an economist perspective, if that makes sense, that there's an economic justice factor here where the developing countries are saying, now it's my turn, and now you're putting this agenda of climate change on me. And basically, if I cannot use those energy sources, I'm limiting my ability to grow economically. And so you benefited, and you prospered, and you developed your economies and your countries for 100 years at my expense, and now when it's my turn, I can't do it.
Yeah, so this is a terrific point. So in fact, whenever there are global negotiations for a climate agreement, there's been, historically when this has happened and remains the case, there's a massive division between the developed countries and the developing countries, and for precisely the suggested reasons. So to a very high degree, GDP per capita is correlated with cumulative CO2 emissions. And it's not surprising. Basically, the Industrial Revolution amounted to people replacing human labor, or the labor of horses and animals and humans, with machines. And the way that was fueled was by having these machines burn coal and other fossil fuels. And so industrialization is really this mechanization of labor where you use fossil fuels as an input. And so the countries that have been doing that for a long time and doing that cumulatively a lot have accumulated the most capital and machines and buildings and infrastructure and other things that are now inputs to economic activity. So the rich countries today are also entirely the biggest cumulative emitters historically, the ones most responsible for the problem. So it's a lot to ask. And meanwhile, we're sort of poised to have huge, billions of people in the world become like, Americans in the 1980s or something. So there's this massive explosion in economic activity among certain regions of the world, especially China and India. And for the world to say you're not allowed to do what we did because it'll destroy it'll have devastating consequences for the world is hugely unfair, obviously. So it's a situation where, to be fair, the rich countries would need to pay for the abatement of the poor countries, but the costs of addressing climate change are sufficiently high that there's, at present at least, no political will in the rich countries for that. So that's a huge part of it. So if you compare climate change to the one example in the world of a hugely successful international environmental accord was the Montreal Protocol, when we regulated ozone. And in that case, chlorofluorocarbons, CFCs, which are industrial chemicals used in all kinds of different things. But they slowly wafted into the stratosphere and then would get broken up by high energy ultraviolet radiation from the sun and start a chain reaction that would kill off lots of ozone molecules and created a hole in the ozone layer, which is the naturally occurring sunscreen of the Earth, sunblock of the Earth. So the rich countries of the world got together in 1987, and about 23 countries, I think, originally signed the treaty. And part of the treaty was a huge pot of money to pay other countries to also stop using CFCs and to switch away from them. But the difference is that the cost of getting rid of CFCs from the global economy was, tiny compared to the cost of giving up fossil fuels. So the magnitude of costs is much higher. The damages still outweigh the costs, but it's a much bigger problem, much bigger cost commitment. Yeah, thanks. I don't mean just cut me off at any point. So.
Just to add one comment linked to the previous comment. Actually, there's a big divide in terms of the policy discourse and policy debate and government responses in developed countries versus developing countries. In Asia in particular, where I work, actually governments do not take care about mitigation activities at all. they predominantly think about only climate change adaptation policies and government responses to it. So that's also another divide between the developed and developing world in relation to the climate change topic.
Yes, it's fair. I mean, one of the problems with this is it's almost it's related to the free rider incentive, but individual countries also have an incentive. There's different ways in which a country can respond to the problem. One is to lower its own emissions, but that has a small impact on the global problem. Another thing you can do is invest in mitigation, like building seawalls or investing in some sort of adaptation behavior that, you know, buying more air conditioners for people or whatever it would be. And there's an incentive for countries to sort of give up on global cooperation or stop investing in protection of the global problem and just protect themselves. And from a poor country perspective, that's probably clearly the narrowly self-interested rational response. And and I think increasingly rich countries are doing the same thing to some degree.
And the worst thing that is developing countries are also divided by all producing countries are in a group of negotiators as developing countries,
Right.
which are making big trouble.
Absolutely.
The oil producing.
All producing.
Oil producing countries, yeah, that's right. Yeah.
Maybe that there would be a way to consider the GDP of the country in the tariff and this how to solve that problem. I mean, the developed and developing countries.
Taxing countries.
Yeah, so
the taxation should be more for developed countries and less for developing to include some index. Or
yeah, I think absolutely. I think the Nordhaus model in the paper I described is sort of it's meant to sort of be a little representative of the global problem without trying to be overly realistic. You're 100% right that in any kind of real-world negotiation, there's the fairness issue that the countries aren't going to participate if it's grossly unfair, and so there has to be some agreement. So in the first in the first global climate agreement, the Kyoto Protocol, which was passed in the late 1990s, it was very so the developed countries basically were going to abate, and the developing countries weren't going to do anything. One of the problems with that is historically most emissions have come from what's currently the developed world, but if you forecast out to 2050, the bulk of emissions are all coming from what's now the developing world. So you can't make much progress on the problem if it's only the current rich countries contributing. But then, of course, the question of who should pay is a wide open question. So very possibly, we need abatement in lots of places. Another economic aspect of this problem is that all countries have cheap abatement options. So there's tends to be like a convex abatement cost curve. So there's like low-hanging fruit, like putting insulation in buildings. That's a very cheap way to get abatement. It pays itself off in a couple years, so it's almost free in some sense. But so you'd rather have people in Armenia putting insulation in their walls rather than getting rid of all the natural gas facilities in Colorado, maybe because it's a lot cheaper per unit of CO2. But it's not fair that Armenia should be doing the abating rather than rich people in Colorado. So there should be some kind of ultimately you need some kind of transfer where there's some kind of global fund to pay for that. That was a big part of the negotiations in Paris was this kind of global fund, and there was a lot of talk about it. It's not 100% clear what will happen, but the rich countries allegedly committed to something like $100 million a year in a global fund. Maybe it's more than that.
100 billion.
100 billion, but per
year, starting from 2020.
100 billion, yeah, okay, that's right, yeah.
100 billion per each year by 2020, but till now, at the first start, it's only 10 billion.
Okay. Sorry, up here you had a question.
My question is what kind of steps economists are going to offer in global policymakers to, like, after Paris Accord, what will be the next solution based on the economic stuff? Is there something going on that perspective?
So there's a lot of economists involved in trying to be involved. They tend to be ignored in the final analysis. It depends what, so there's lots of proposals and suggestions. I think it's a wide open question. I think, in my personal opinion, ultimately this is an economic problem, and it's a problem that economists have a lot of insights in that need to be acted on. But it's very limited how much that's actually been the case to date. So I don't know. I'm hopeful that will slowly change. I think it's starting to change. That the people are starting to recognize the Nobel Prize in economics going to this kind of work is indicative that there's some movement in recognition of the importance of these kinds of insights. But it's also part of the problem is it's easy. What's the short-run incentives of a political actor? They want to appear like they're doing something and they're contributing to the problem. They might be able to do that without actually incurring the necessary costs to actually make progress on the problem over the long run. So there's, we hopefully, I think there has to be, the world will have to recognize this as a really important problem and prioritize it as an important problem before we're likely to make progress in the direction of committing to these kinds of arrangements.
I can do one more question.
Yeah.
In this North Pole analysis, there is options for thinking about per capita emissions. So having the limited resources, these limited resources have to be distributed per capita, and from per capita principle to make the equalizing of the economic model.
So I don't fully understand.
So there is this theory, not theory, but the fact that we have a balance for the reaching 2 degrees of Celsius. It was 3 years ago. It was.
So as a commitment, we want to
commitment to have we have 1,000 gigaton of balance to reach 2 degree increase of the global temperature. So let's divide this 1,000 per capita, and to say that this is the limit, equal limit, so equity principle for all population of the globe, and let's start from this point and begin to tax accordingly.
So that's a great suggestion. In fact, I have some of my students do an exercise a bit like this. So I teach a class on this stuff for senior majors at CSU, and I have them pull data on cumulative emissions by country and emission, and sort of ask what's a fairness principle? What would be a fair way to allocate the budget of how much carbon we're allowed to burn until we hit 2 degrees or something? The problem is that what you get is that the US overburned its budget decades ago, and various other, basically all the powerful rich countries overburned their budget, and now the poor countries get to abate a lot. So you end up to a strict kind of fairness principle gets you to something that is wildly politically unrealistic given the balance of power in the world. Like it's not a equilibrium that people are going to negotiate to, but it's an important reference point, right? It's an important observation that if you think of each human on the planet as having the right to the same cumulative emissions per capita for a citizen from their country or something, then you see how starkly it is the case that we're, the rich countries have already burned through their budget and the poor countries haven't. And so it's actually a very revealing exercise because it shows that, and it also leads you to realize, oh wow, this isn't gonna get us very far in terms of negotiating maybe, but it's a necessary reference point for any kind of reasonable discussion of the problem.
If you are interested, I can share Armenian position under Paris Agreement, and it is based on per capita emission.
Yeah, I'd love to. That'd be great.
Equity principle.
That would be great. Yes. Thank you. Great. Yeah.
Just another comment. Socially speaking, maybe it's also important the awareness of the people regarding the damage or the environmental issues. So maybe including some classes in schools or universities, mandatory classes, yes, regarding about the environmental issues. So maybe that will prevent the future damage to the environment.
Absolutely. I 100% agree with you. I also think it's more than just, for this problem, it's more than just understanding the science, because ultimately the solution is fundamentally requires it requires a sufficient level of economic literacy as well to understand the nuances of the problem. So there's also yeah, economic education is also a piece of it, but I completely agree. Everyone should feel free to leave, by the way. Everyone
It is 9 o'clock.
I just have one little question.
Yes.
I don't know if it will make sense or not, but I'm thinking maybe it will make sense not to put pressure on countries, but rather on companies. Because as far as I know, there was some research that most of emissions go to 10 global companies.
Right. I think it's a fantastic idea, actually. And there's people starting to talk about this kind of thing, like how can we build up an agreement at the level of companies and subnational governments, states or cities or others, and an amalgam of those kinds of actors. It's complicated because so I described the leakage problem before. So there's also an observability problem. Like if you want to, Apple Computer makes iPhones and there's this massive distribution channel that has all kinds of energy inputs, but no one really observes it, and an iPhone might be, passes through 15 or 20 different countries on the way to being produced. And so having transparency and tractability about how you actually know what the emission decisions of companies are is complicated. So but I agree with you that and there have been actually noteworthy and important commitments by corporations to do actions that could potentially add up and be cumulatively very important in addressing the problem. But it is complicated. I would at least say that. But it may be that's exactly what we need to be thinking about. Economists haven't done enough research on that type of thing, I think, and there's probably room to try to think about actual mechanisms or information disclosure systems that could allow consumers to understand what the emissions of particular companies are and things like that. So I think it's a great idea.
Because I'm thinking maybe if there will be some research, 100 companies will be interconnected, and in the end it will be 10 companies.
Where the emissions are actually coming from, yeah.
Well,
yeah.
The decision makers will be 10 people, for example, or 10 companies.
Right.
It's
It's also not clear to me what a lot of those companies are going to be energy companies, ExxonMobil or something, right? So what does it mean? Do we then just tax ExxonMobil? ExxonMobil's in the business of selling fossil fuels, so if countries are willing to demand the fossil fuels, you can tax the fossil fuels, although actually in the case of taxing, say, gasoline, are you an economist or are you an environmental person?
I'm an economist.
So economists think about the incidence of a tax, like who actually feels the burden of the tax. In the case of a tax on gasoline, because the demand elasticity of gasoline is very high, or it's a steep demand curve, if you change the price, it's a flat demand curve. If you change the price, people still demand the same amount. So what happens is that the incidence of the tax gets passed almost 100% to the consumers anyway. So it's not as clear and obvious as you might think. So it would end up looking to the citizens of a country like they were taxing carbon anyway. So if there's no political will to do that, there might not be a political will to tax the company. So it might just be kind of passing the buck. But there's definitely room for thinking about how we work around the lack of commitment at the national government scale. Thanks. Yeah.
When you say that we are imposing the country, doesn't that mean that indirectly we impose the companies? Because when we impose the country, then the government will pay, will give high weight to its local companies, whose damage is high in the globally speaking. So when we impose the country, it means that we indirectly impose the companies. So what was the purpose of?
So I was just thinking the difference between the government passing, say, a carbon tax and the government saying we're going to force ExxonMobil to pay a tax,
Yeah.
the burden of the tax gets passed on to the consumers largely in that case anyway. So you're still effectively passing the tax. Right, right.
So, coming back to economics, we need to be a little bit cynical and healthy cynical, and whatever is happening is actually following what the economic models should predict actually for wealthy countries. There is no incentive to cooperate, absolutely. And even if I want to cooperate, if I put a deduction in terms of present value versus future value, I better save as a rich country whatever money I want to invest. And in the future, if something happens with the climate, I can build a wall and protect my country.
I mean, there's an incentive for the rich countries to participate in a global agreement. So if there were a global agreement, according to this, the U.S. has its GDP in 2100 is 30% lower than it would be without climate change. So I mean, that's probably higher than it actually will be. Although if you take into account the cumulative effects of economic growth over time, it's conceivable. But whatever the case, there's potentially large stakes. Most of this is happening 100 or 200 years
Exactly.
from now.
That's why when you put a healthy discount in terms of what happened in the past versus in present, you better grow presently. In the future, if something happens, you will just build a wall or find new sources or deal with the problem back then rather than stop your growth right now. So
but a lot of the impacts aren't stuff you can build a wall for.
I mean, it's economic policy.
500 years from now.
We think we can protect it. Yeah.
Economic policy making is very much short term. It's very much aligned with political life.
Yep.
It's like 4 or 5 year election cycles or whatever.
Oscillation of elections.
And so it's very hard to make these long term decisions. One would say, however, that the U.S. is not planning its energy supply for the next 5 years. They're planning for the next 50, 100 years. And that's probably, we have Syria going on. There's this, I think there's, when it comes to consequences of energy use, energy policy, the environmental consequences, there's much more difficulty motivating cooperation.
Yeah.
Yeah, I would add that the Nordhaus model, for example, assumes a pretty high discount rate, so 5% discount rate. So there's a huge amount of damages happening in his model, but they get discounted into very little in the present, because nothing that happens beyond 100 or 200 years matters with that big of a discount rate.
Yeah, actually, I like that model because it was showing that a little bit commitment actually will be much more beneficial in terms of cost efficiency than a lot of commitment. So
yeah.
That one was realistic.
Yeah, no, he definitely errs on the side of realism. He's very much, yeah. Okay.
Force exit.
Yeah, thank you, Terry.
Thank you so much.